Hello friends and welcome to my channel. If you will watch this video, you will learn about this temperature speed fan control, why I like the most and how it works. Let's get started. First of all, I have to tell you that I tried a lot of schematics, but from all, this is that I like the most, and I will tell you why. And all of this, it's made from salvage parts. This thermistor, it's from this BMC for laptop battery. This is from a bad laptop battery, and this is the thermistor. And the rest of parts are salvaged from scraps. So this schematic was not made by me. I reverse engineer from this power supply, and I took all the parts, and this SMD I replaced with normal resistors. And now let's see how it works, and after that I will explain you how it works, this schematic. It's put to the power supply. Let's power it on. Let's put it to 12 volts. And now you can see the fan is turning. Now let's measure the voltage to the fan. This is ground. So we have 12 volt supply voltage, and to the fan it's only 6 volts. Now let's hit this thermistor, and you will hear and you will see the speed will increase. You can hear was to the maximum speed, and now it's cold and decreasing. Depends on what cooler you have, you can make it to start turning only over 30 or 40 degrees. Depends on what you are using for. I hope that you have seen my previous video about SPL 700 amplifier. I made a PCB just like this, and I use exactly this schematic. Now let's explain how this works. You will find the schematic and all the explanation in the description in a link. So here it's the most important part, it's the thermistor. In the original schematic it was 100 kilo ohms. but on this version I had only 10 kilo. And that's why I modified, instead of this 3.3 kilo resistor, I divided by 10 and I put 330 ohms. But if you find this 100 kilo thermistor, you can keep all these original schematic. This capacitor, when we first apply power supply to this device, will act like a very small resistor for a short period of time, and for 3 or 4 seconds this capacitor will start the fan, and after this capacitor will charge, then this fan will stop. This is a resistor that is connected to this point. This point is very important because when I forgot to tell you, this thermistor is NTC, negative temperature control, and when the temperature is increasing, his resistance is decreasing. So when we hit this thermistor, his value will go down, and when this value will go down, this voltage also in this point will also decrease. When this voltage is low, through this protection resistor, these two transistors will have the voltage, base emitter voltage, so they will close. This resistor, it's for limiting the base current of this second transistor. So this resistor will reach to the ground because this fan has a very small internal resistance, and that's why even this potential, it's plus VCC. I will show you that this resistor will pull down the potential to this base of first PNP transistor, and this will close the second transistor. Now let's show you. So this is ground, this is VCC, this is output. This voltage is applied to the fan, and now let's measure the voltage on a thermistor. So we have 11.5 volts, and now let's measure from thermistor to the VCC. You can see there is only 0.5 voltage drop, and theoretically these both transistors should be open, but now I will measure in the base of the first transistor. And now in the base of the first transistor we have, let's measure from VCC, 1.1 drop voltage, and that's why the fan is turning. If you want to stop the fan and start only over one fixed temperature, you can take down this resistor, and then the fan will start only when this potential is dropping. This transistor, this third transistor, is usual PNP transistor with 30 volts collector emitter voltage. This one, second transistor, it's also usual PNP transistor, but this should have 1 amp current, should manage 1 amp, and also minimum 30 volts collector emitter voltage. Now I want to show you something interesting. You can see this schematic. There is no stabilization anywhere, and this voltage, it's depending on VCC. And now let's show you. If we increase the input voltage, you can hear the speed is growing. If we decrease the voltage to 8 volts, this completely stops. And now let's hit. You can see it starting. And after it's cold, it's stopping. I invite you to make this kit when you need a temperature controlled fan, because sometimes if this fan is full speed will make a lot of noise, and when the heatsink is cold you don't need this at full speed. And that's why I recommend fan control speed for any cooler. If you have questions, please put it in comments. I hope that you find this helpful, and if it's true, please like and subscribe. Thanks for watching. See you in my next video.